so this is the second half of the graphing review. Again, I would recommend that you try them first and then just fast forward to check your answers, and if you need to, watch the parts that you don't understand. All right, so this one requires that we find the domain, right? Find all of the asymptotes and then graph the function. So domain, remember, we're talking about the denominator and the fact that the denominator cannot equal 0. So we can go ahead and solve that. So we would subtract 16 to get 4x equals negative 16, divide by 4. And x equals negative 4, and that's what's not allowed. So that tells me that my domain is every number except for negative 4. So everything from negative infinity to negative 4, unite it with everything from negative 4 to infinity, but not including negative 4, which is why we put the parentheses. That also tells me that my vertical asymptote is at x equals negative 4. And we'll go ahead and put that right in the middle of our... That'll go right in the middle of our table, okay? Then we're going to go ahead and do our horizontal asymptote, right? And remember, our horizontal asymptote, it depends on what the problem looks like. So in this case, since my degrees are the same, they both have an exponent of 1 in the top, all we do is we look at our lead coefficients. So since exponents equal in numerator and denominator, you do divide the lead coefficients. Y equals the division of the lead coefficients. So in this case, my lead coefficients are 8 and 4, so y equals 8 divided by 4, which means my horizontal asymptote is at y equals 2. And I would go ahead and put those in right away. So at x equals negative 4, I'll go ahead and put my vertical asymptote, make it dotted, right, so we know that that's there. That's an asymptote, not an actual graph. Then the horizontal asymptote is at y equals 2. Again, make it dotted, so we know that's an asymptote and not actually part of the graph of the function. Then we can go ahead and type this into our calculator, right? So we go in there. Remember, though, that when you're typing this in, you need to make sure you put parentheses around the top and the bottom to indicate to your calculator that I'm taking all of this and dividing it by all of this. So 8x plus 2 in parentheses, divide it by parentheses 4x plus 16. Okay, so now we can go ahead and graph it to see how it looks. So when I look at this, right, I can tell that we're going to have something in this section and something in this section of the graph, but we have to go to our table and get some points. So negative 4 was my center point, right? So then we'd go up negative 5, negative 6, negative 7, negative 8, which is 3.9, 4.5, 5.8, and I'm just estimating 9.5, and then this one is the error, right? And then we have to do the same thing in the opposite direction. So negative 3, negative 2, negative 1, 0, which is 0.125, negative 0.5, negative 1.75, and negative 5.5. So now we can go ahead and we can graph those. So in this section, negative 8, 3.9 would be close to 4, negative 7, 4.5, so halfway above, negative 6, and then 5.8 would be close to 6, negative 5, and then 9.5 is 9, halfway between 9 and 10. So we get a graph that looks something like this, right, as it gets closer and closer to the asymptote, but not actually touching it. And then the same thing over here. So negative 3, negative 5.5, half further than 5, but not to 6, negative 2 and negative 1.75, negative 1, negative 0.5, 0, and slightly positive. So now we've got something that looks like this happening. Okay? All right, so now let's go ahead and look at number 3. Okay, so number 3. Again, we start out with thinking about domain, which means the denominator cannot equal 0. So x squared plus 10x plus 25 is not supposed to equal 0. So this one we'd have to factor. So what multiplies to 25 and adds to 10 is 5 and 5. So we would have x plus 5 equals 0, which means x equals negative 5, x equals negative 5, and that's what it cannot equal. So that tells me that my domain is everything from negative infinity up until negative 5, but not including it. Unite it with everything from negative 5 to positive infinity, and that my vertical asymptote is at x equals negative 5, so that'll go in the middle here, which we know should give us an error when we graph it. And then we need to find our horizontal asymptote. Now in this case, we have to be careful because our horizontal asymptote, in this case, my degrees are different, right? My top degree is smaller than my bottom degree. So the top degree, or I should say exponent, means the same thing, right, is smaller. So when that happens, we look at y equals the number at the end, the part that's not part of the fraction. So in this case, it's a negative 4. So y equals negative 4 is my horizontal asymptote. So I'm going to go ahead and create those asymptotes. So y equals negative 4. All right, and then I'm going to create my vertical asymptote at x equals negative 5. All right, then I'm going to type this in the calculator. And this one is actually really tricky to type into the calculator because when you're doing this, we have this happening at the end as well. So we're going to have a lot of parentheses here. We have to have an overall parenthesis going around all of this, as well as a parenthesis around the top and a parenthesis around the bottom. So when I go to type this into my calculator, I'm going to start out with the big parenthesis that's around the whole thing, and then I'm going to go to the top. So I need to do a parenthesis again, x parenthesis, divide it by, now everything in the bottom goes in a parenthesis, so x squared plus 10x plus 25, end that parenthesis. But now I also end the overall parenthesis for the fraction, and then minus 4. Now if you actually used the fraction function, that would probably be easier to type in, but you're going to get fractions in your table instead of decimals, and I'd rather graph a decimal than a fraction. So I prefer to put it in this way so I can avoid the fractions. So graph. So when I look at this, this tells me that I'm going to have something happening here and here, but let's look at our table to get our values. So I want to be at negative 5, and since I have below negative 5 here, so we'll go below. So negative 4, negative 3, negative 2, negative 1, which is at negative 4, basic 4.1, negative 4.2, negative 4.8, negative 8, and then we can scroll up to get the other ones. So negative 6, negative 7, negative 8, negative 9, which is negative 4.6, negative 4.9, negative 5.8, and negative 10. Okay, so we can remove that and go ahead and graph these. So negative 9 and negative 4.6 is closer to 5 than it is to 4. Okay, negative 8 and negative 4.9, closer to 5, negative 5. Negative 7 and negative 5.8 would be closer to 6. Negative 6 and negative 10 is here, so that tells me that we've got something like this happening, right? Then we need to do the same thing on the other side, so negative 4 and negative 8. Negative 3 and negative 4.8 would be closer to 5 than to 4. Negative 2 and 4.2, we're getting closer. Negative 1 and 4.1, again closer, so this is where we're going to come around, right? And then this will get really, really close but never touch our vertical asymptote. And it does look like our graph, so we know we're good. All right, so make sure you review anything for the test for tomorrow, and good luck on it.